Emilio Martinez.
And I'm Manuel Padilla Jr. And today we're going to present to you guys how to do function behaviors. Our problem is find the intervals on when f is concave up or down, the points of inflection, the critical points, and the local minimum and maximum. So our first step is to take, and our problem is f of x equals x over x squared plus 27, and then you can tell that's the quotient rule. So for step 1 we had to take the derivative, which is, so we use the quotient rule, and then the x is u, and then x squared plus 27 is v, so we take the derivatives of those, so u equals x, and then u equals 1, and then v equals x squared plus 27, v1 equals x 2x, and then the quotient rule is u prime v minus uv prime over v2, and then from there we substituted all of these into what is the equation.
Step 2 is find the critical numbers, and we use a calculator for the top portion. We set it equal to 0, and this is our two possible solutions. We get x is equal to negative 3 square root of 3, and x equals 3 square roots of 3, and we simplified it to x equals negative 5.9615 and x equals 5.19615.
Now we'll have to find the second derivative of x equal x over x squared plus 27, and so we plugged that into the calculator, and we got 2x times x squared minus 81 over x squared plus 27 square root of 3, and then we set those equal to 0 you put that into the calculator and you set it equal to 0 to solve, and these are three possible inflections: x equals 0, x equals negative 9, and x equals 9.
And the next step is to perform the derivative test. Therefore, we chose the critical numbers that we received from the previous derivative, the first derivative, and we chose numbers from negative 5.19 to negative infinity, and we chose negative 100, and we chose negative 1, 4, and 6. We plugged these numbers back into the first derivative, and we got negative, positive, positive, and negative. Then we found out that at from this point negative infinity to this point negative 5.196, it's decreasing. Negative 5.19 to 0, it's increasing, and from increasing is negative 5.196 to 5.19, and it's decreasing from 5.19 to infinity. And the local max is 5, and the local min is negative 5. The numbers we got from the possible inflection points, we got negative 9, 0, and 9, and we chose numbers between those intervals. We got negative 100, negative 1, 1, and 100. And from these points, it's concave down, concave up, concave down, concave up. And this is, we got these numbers and we plugged back into the second derivative of the function.
Now a summary of the entire problem. F is concave down at negative infinity and negative 9 and 0 and 9 because f double prime is less than 0 on those intervals. F is concave up at negative 9 and 0 and 9 and infinity because f double prime is greater than 0 on those intervals. F is decreasing at negative infinity and negative 5.19615 and 5 and at 5.19615 and infinity because f is less than 0 on those intervals. F is increasing at negative 5.19615 and 5.1615 because f is greater on those intervals. Local max at x equals 5.19615 because f prime changes from positive to negative at x equals 5.19615. Local min at x equals negative 1.19615 because f prime changes from negative to positive at x equals negative 5.19615.